To start today, I want you to try these two questions on recent topics. Pause the video, have a go now, and then I'll go through them. Okay, going to go through the first one to start with. This is a situation where we are changing the ratio. Alex and Bola have some money in 2 to 5, and then Bola gives £6 to Alex, so the ratio changes. Okay, the first thing to do is write down that Alex and Bola, well, they have 2 to 5, but the total number that they're going to have is going to be 2x to 5x, where x we need to find. And then afterwards, we know that Bola gives £6 to Alex, so Alex is going to end up with 2x plus 6, and Bola is going to have 5x minus 6. And that is going to now be in the ratio 1 to 2. But we can't set it equal because whilst this is the total number, this one is not. So we need to use our knowledge of what's going on. We need to think the fact that we can link these together and sort of timesing by a scale factor, and that scale factor would be 2x plus 6 over 1, but it would also be 5x minus 6 over 2. This is our classic way of dealing with this now. And actually this is not too bad. The divide by 1 will just be, I can just get rid of the dividing bit, and then I can multiply through by 2. So it's going to be 2x plus 6 equals 5x minus 6. 4x plus 12 equals 5x minus 6. Minus 4x on both sides, add 6 to both sides, x will equal 18. And we're nearly there. How much do they have altogether? Well, they've got 7x altogether, so it's going to be 7 times 18, which is this 126. Whew, I think this is a hard topic in ratio, but hopefully you're happy with it now. Okay, second question. This is just sort of linking into this earlier statement I had here, the fact that when I've got two ratios, how can I link them together? Well, I know, I think the 2 to 6 is a little bit confusing actually, but I think it's meant to help you so you can see that 10 divided by 2 is the same as 30 divided by 6. There's this like constant scale factor that I'm multiplying by to go from 2 to 10 and 6 to 30. This question maybe should have been before the other one, because if you've understood that one, you're probably okay with this. So is this one true? Well, yes, because it's like it's the same sort of thing that I've got here. As long as I've divided corresponding ones by each other, then it's going to be absolutely fine. So this one's going to be true. If we look at the next one, A over C is B over D. That's just these two flipped around. So that one's going to be absolutely fine as well. However, when I start getting one like trying to link D and A and C and B, that's not going to be the case because I don't have it. I can't do that. I can't have scale factors that go from here to here because they're different quantities. And so actually that's going to mean that some of the other ones are going to be incorrect as well. However, we need to be a bit careful because you can see here to go from here to here, here to here, I basically multiplied through by 5. And actually 6 divided by 2 is equal to 30 divided by 10. It's not the scale factor as such that goes between these two. It's the scale factor that goes between how do I get from 2 to 6? I times it by 3. How do I get from 10 to 30? I times by 3. So actually this one's going to be true as well. And this A over C, okay, that's not going to be true because you can see we've already got the true one. I can't just flip it around. A over B is C over D. Is that true? Well, actually that one is essentially equivalent to that one. I've just flipped it round, so that is going to be true as well. Yeah, I hope that makes sense. And the fact that from ratios we can write fractions, And I suppose the main thing to take out of this is this is what we've looked at before. Actually, this is a sort of slightly new idea that I hope you're okay with. Today we're going to look at overlapping ratios, but before I tell you what overlapping ratios is, I'd like you to try this little starter question that's going to link into today's topic. So pause the video and have a go. Okay, I've got three things that I'm comparing, but I can instead just compare two. There's nothing wrong with that. And sheep to cows is going to be 10 to 6, which then simplifies to 5 to 3. Meanwhile, cows to pigs is 6 to 21, and I can divide both by 3 to give me 2 to 7, and that's my answer. Well, when we do overlapping ratios questions, this is actually what we start with. So this is a typical question. On a farm, the ratio of sheep to cows is 5 to 3. The ratio of cows to pigs is 2 to 7. What's the ratio of sheep to cows to pigs? And the overlapping bit is here. I've got a 3 and I've got a 2, but I know at the moment I don't have it all linked together. Now we know the final answer is going to be this, but how could we get it just from this question here? Well, the process I've just gone through here basically explains it. Before I simplified it, I had these two the same. And when I have these two the same, I can put it back into this ratio. So what I need to do is make these numbers the same. And I can do that by I can times this one by 2, and I can times this one by 3. And at that point, I've made the cows 6 in both, and then I can get back to that original answer. And what have I essentially done? I've multiplied this one by that 2 and this one by that 3, but actually I've found the lowest common multiple of 2 and 3. That's going to be the method that we use. Let's have a look at an example from scratch, because obviously going through this example, and I've kind of already done it, makes it, well, it's meant to give insight, but it also, doesn't show the process from the start. So if you're feeling confident, pause the video and have a go at this one now. Okay, so the overlapping ratio is this girls part. You can see I've got girls in both ratios, but I want a ratio with them all in. So how can I do this? Well, I've got boys to girls is equal to 5 to 6, and then I've got girls to adults as 4 to 1. I'm just laying it out again to try and make it clear. Okay, now I want these two numbers to be the same. Now I could just multiply this by 4 and this by 6. Actually, that would work. But instead, I can find the lowest common multiple of 4 and 6. This will just make it a bit easier. And actually, that's equal to 12. So if I want to make both of these 12, I'm going to multiply through by 2 here, and it's going to become 10 to 12. I'm going to multiply by 3 here, and it's going to become 12 to 3. And look, I've made them the same now. So overall, it's going to be 10 to 12 to 3. And that is my final answer. I would recommend you lay it out like this. Just take your time. This overlapping part, essentially, you have to make the same. Okay, I've got 5 questions for you. What I'd like you to do is pause the video, have a go at these 5 questions. Okay, I'm going to show answers for this. Hopefully, you're like this right now. This is a slightly different take on overlapping ratios. We still have overlapping ratios because we've got women to men and men to children. However, this time I'm given one part, and I'm asked for like what the total number of people is, i.e. I need to know the total number of parts. So we're going to tackle this problem 2 ways, and the first way is going to be to use overlapping ratios. So I've got women to men 5 to 3, and men to children 7 to 4. And I want to get these overlapping parts the same. So what I can do is I can multiply this one by 7 and this one by 3. And then I'm there. I've got women to men to children. It's 35 to 21 to 12. Right, if I represent this roughly as a bar diagram, then I know that these 12 parts are worth 48. So one part is going to be 48 divided by 12, which is 4. And then if I want to know the total number of people, I need the total number of parts. So that would be, I need to add these all up. Okay, that gives me 68. So how many people it's going to be 68 times 4, which is 272. Okay, really solid way of doing that problem. There is another way of doing this problem that perhaps you thought about. In this case, because we're not asked for the ratio, we could actually just use the one part directly to get the number of men. So it would be, we'd see that this is worth 48 now. So one part in this ratio would also equal 12. And so 7 parts, sorry, it wasn't 12 before, it was 4. Sorry, 1 part would equal 12. So 7 parts will be 7 times 12, which is 84. Okay, so actually that's the number of men. I've got the number of children, so all I need is the number of women, and I could add those together. Now I can look at the other ratio, and I see I've got 5 to 3, but I know the number of men, that's 84. So this time, this ratio, one part's going to be 84 divided by 3, which is 28. And then I can do 5 times 28 to get 5 parts, and that's going to be 140. So if I add those up, 140, 48 and 84, I also get 272. So just an alternative way of doing that question. Okay, I want you to try some more now. So, you know, these ask similar sorts of questions, but there's all sorts of things being asked. There's some slightly different types of questions later on. So pause the video and have a go at this section B, lots of questions. Get through as many as you can. Okay, I'm just going to show the answers to these. There we go. Again, hopefully you're happy with these. You can now deal with overlapping ratios really effectively. Well done.